My role is the area architect for infrastructure efficiency. That means I work hard with all of our engineers to find projects that can help reduce our costs and increase the performance of the product. I started a project called Tiny House with those goals in mind. Hi, my name is Murray Stokely. I've worked at Snowflake about 1.5 years now. Earlier in my career, I spent the last couple of decades optimizing private cloud infrastructure. With Snowflake, I was really excited about how we partner closely with all of the major cloud providers, and we had this opportunity to focus on all of the efficiency programs, all of the work on performance that I've been doing in my career on top of the public clouds, and it's been a really fun ride. I chose the name Tiny House because I love these little pictures of beautiful houses in the forest with this movement to help us do more with less, right? And so we take our inspiration for the Tiny House program out of this philosophy of doing more with less. Throughout that work, I devised this Tiny House program. So I wanted to come up with a set of metrics and a set of reviews where we could go through and with a portfolio of engineering projects that we think offer the highest ROI. So we've been growing very rapidly for many years, and I wanted to make sure that we were also balancing those new customer features with some discipline to ensure that costs were staying in track so that we could ultimately invest more in new features and pass on savings of performance and cost to our customers. Tiny House was extremely successful last year. We set an ambitious goal and we crushed it. So I'm happy to report that we've set even more ambitious goals for this year, and we're just getting started. Tiny House is really exciting because we get to go back and look at all of the fundamental assumptions of what makes Snowflake work. Right now, we're handling over 5 billion queries a day over exabytes of customer data. But if you go back just a couple of years, we were working at much smaller scale. So the sorts of engineering trade-offs that we made about how to design our systems and how to interact with the cloud providers, they were much different just a couple of years ago, and costs that might have been very negligible or inconsequential have grown as the total business has grown. So I think it's been really exciting to get to understand all layers from storage to compute, machine learning training and inference, and all of the exciting products we're doing to find where are the biggest costs for our customers, what are the biggest levers we have to improve performance and reduce those costs. Snowflake culture has been fantastic to become a part of. We've got a great group of people from a variety of different backgrounds all working together to solve real problems. It's the kind of place where people roll up their sleeves and they help each other and they dive in. People write code, people work together on design docs. You never have to sort of ping people for your code reviews or for help out with the project. People are eager to please. And I think it's a really exciting environment. People move fast, but we also have a lot of fun together. I've had the opportunity to work with the Arctic team since soon after the Neeva acquisition, and it's been fantastic to see all of the energy in this space. We've been working hard with partners to gather the best training data, to build the best engineering team, and to get the best use out of these scarce GPU resources. So from a Tiny House perspective, we quickly realized that building out these training clusters would be a very large cost for the business, and finding ways to keep those GPUs utilized as much as possible would be one of our competitive advantages and why we believe we've built one of the most cost-effective LLMs in the industry right now. Tiny House is a portfolio of more than 100 different engineering projects, but there's a couple of similarities you'll see with most of them. First, we tend to be very involved with getting the data. Then we look at building statistical models to understand where there might be opportunities for optimization. And then finally, building prototypes or moving to production software changes that help us realize those savings. One of the main benefits of Snowflake is how compute and storage can be scaled independently. So when a customer comes in with a bunch of new workloads for us, we want to scale up the amount of available compute capacity so that we can answer their queries as quickly as possible. So we try to find the middle ground with statistics. We do this by building statistical models, forecasting customer needs, and finding just the right amount of excess capacity that we keep on hand at all times. And we call this free pool optimization, and it's just one example of 100 different engineering projects that we look at across the stack, from hardware, kernel, through spot instances and reserved instances, and all areas of cloud optimization in the middle. We set an ambitious goal last year of infrastructure savings for Tiny House, and I was super happy at the end of the year to celebrate how we crushed that goal. Going forward for this year, we set even more ambitious targets. We've gone through and we've identified a series of additional areas where we think we can offer better performance to our users and reduce costs. And we're really happy to get the best benefit out of the new hardware and pass those savings on to our customers.